Welcome once again to another time value of money video. We're looking at the advanced time value of money questions and answers. Let's look at number 2. You take out a 20-year, 6%, $250,000 mortgage. Immediately after you make your 24th regularly scheduled mortgage payment, you then decide that you want to have your loan paid off in the next 5 years. You wish to accomplish this by making a principal reduction payment each time you make a regularly scheduled mortgage payment, beginning with your date 25 payment. What is the requisite size of the monthly principal reduction payment annuity? Great question. Here's the answer. So here we have the cash flow date line. At date 0, we get the $250,000, and then we start making the payments. And I'll just jump to step 1 real quick. Step 1 is where we determine the size of the payment. As you well know, the payment for a fully amortized fixed rate level payment loan is the loan amount divided by the appropriate PVIFA. Here the opportunity rate of return monthly is 0.06 divided by 12, or 0.005, 0.5% per month. And N is the number of payments, 240. That's 20 years times 12 payments a year. And when you do the algebra, you get 1791.08. So back to the cash flow date line. At date 0, we get the $250,000. At date 1, we pay the 1791. I leave the pennies off. At date 2, pay 1791, and the plan is up to date 240 to pay 1791. However, this problem says that we're going to make the first 24 payments of 1791, and then beginning at date 25, we want to add something to that, so that within, not within, but actually exactly 5 years later, we actually 5 years worth of payments, 5 years worth of monthly payments later, the loan's paid off. So beginning at date 25, we'll make 60 payments, and that means we will have our last payment at date 84. And the amount shown here is X, and the loan's paid off at X. So the idea here is if we make a payment of a total of X dollars at date 25 and 26 and 27 all the way to 84, when we make that X dollar payment at date 84, the loan will be paid off. Okay, so let's see how we do that. Well, step 2. The remaining principal balance at date 24, as we've seen before, is the monthly payment, $1791.08, times the appropriate PVIFA, which in that case would be one with an opportunity rate of return per period of 0.5%, and 216 remaining payments. Why 216? Why is N 216? Because 240 minus 24 is 216. We've already made 24 payments. We have 216 left. So the remaining principal balance at day 24 is just the present value of all the remaining future cash flows, which is 216 payments of $1791.08 each. And this is what we get. $1791.08 times, here's the computational formula. And when you do the arithmetic, you get $236,239.65. Okay? So that's the remaining principal balance at day 24. Well, step 3 says, okay, we're reminded that we're going to use application formula 4 again, a very popular application formula. Present value of the annuity equals annuity cash flow times the PVIFA. In this case, the relevant value for the present value of the annuity is the remaining principal balance at day 24, $236,239.65. And the way we set this up, the annuity cash flow there is just X. Okay, call it X for the moment. And the PVIFA has an opportunity rate of return R of 0.5% a month, 0.005, and an N value, number of cash flows in the annuity, of 60. So we're solving for the value of X, which would be a total payment made at each of dates 25 through 84 that would allow us to extinguish this loan balance in 60 payments. And so here's what we do. Here we have the same 236 on the left-hand side, and then that PVIFA happens to be equal to 51.7256. Then X, of course, is just the is just the remaining principal balance divided by the PVIFA. And lo and behold, the value of X is $4,567.17. So this means if we pay $45.67.17 at date 25, 26, 27, all the way to date 84, the loan will then be paid off when we make the date 84 total payments of $4,567.17. That's the value of X. But remember, X includes everything we pay. But part of what we pay is the contractually required amount of $1791.08. So let's look here at step 4. Step 4 says we must make 60 payments of $4,567.17 to extinguish the $236,239.65 remaining principal balance of date 24. Since $1791.08 of the $45.67.17 payments is the contractually required payment, the monthly principal reduction payment annuity is $45.67.17 minus the $1791.08, or $2,776.09. A total of $4,567.17 is paid from date 25 to date 84, and then after the date 84 total payment of $45.67.17, which again includes $1791.08 of the contractually required payment and $2,776.09 of the principal reduction payment annuity that we're voluntarily making. And so again, a total of $45.67.17 is paid from date 25 to date 84, and then at date 84, the loan is fully paid off. The second F is not there. But so at date 84, the loan's paid off. And so the answer to our question, the way it was asked, the question that was asked was, what is the requisite size of the monthly principal reduction payment annuity? Well, that specific answer would be $2,776.09. And I think that's a great problem. There's a lot of stuff going on there. Please spend some time studying that. And thanks for watching.